Today's question is unique path 3, and this question is marked as hard. So let's go and see how can we make this an easy one.
Drove the gates, feeling anxious around 12 a.m. Just move, but might move it all out again. This feel like deja vu. Swear last year my brain bought the same thoughts through. I blame the things I do. Only difference is I ain't in school.
In this question, we'll be given this grid as an input, and we need to find the number of unique possible paths from the starting node to the ending node, covering all of the zeros. And in this grid, 1 represents as the starting node, 2 is the ending node, 0 is the walkable node, -1 is the unwalkable node. And from any given node, we can only move either up, down, left, or right. So for this input, there can be only 2 possible paths from which we can move from from the starting node to the ending node by traversing all of the zeros. That is the walkable path. So let's see what are those paths. So suppose we are at the starting node and we took a right, then we took a right again, then right again, then we move down, then left, left, left again, down, then right, and then right again. So we reach the ending node. So this is one possible path, and the second possible path is from 1 we'll move down, down, then right, then up, up, right, right, down, left, and down. So this could be the other possible path, and there can be only 2 paths for this input. Yeah. So how can we do this? We can explore every possible paths from the starting node to the ending node, and we can maintain a count of zeros so that at the end we can check if the count of zeros is 0 or not. If it's 0, then we can increment the total count. So let's see how will we do that. So initially we'll have the total count as 0. We'll have count of zeros also. So zeros count will be 9 for this grid, right? And let's say our exploration order will be upward, downward, left, and right. So from the starting point, from the starting node, we'll first see if we can move up. We can't. Then we'll check if we can move down. We can. So we move down, we'll mark this as visited. From this node, we'll check if we can move up. We can't. Now we'll check if we can move down. We can. So we move down and we mark this as visited again. Now from this node, we can't move up. We can't move down, we can't move left, so we have to move right. Mark this as visited and move right. From this node we can move up, we'll mark this as visited, we'll move up. From this node we can move up, we'll mark this as visited again, we move up. From here we can't move up, we can't move down, we can't move left, and we can move right. So we move right and we'll mark this as visited now. So from here, from this node, we can't move up, but we can move down. So we'll mark this as visited, the previous node, and the current node will check we can move up or not. We can't move up. If we check, now we'll check we can move down or not. So we can move down. So we'll mark this as visited, and we moved to the ending node. So now at the ending node, we'll check if our zeros count is 0 or not. So as we can see in this traversal path, we left 2 of the zeros. So here our zeros count will be 7. Not 7, it will be 2. Because we traversed only 7 paths. So 9 minus 7 would be 2. Right. So we won't increment this total count. And now we'll backtrack and we'll check if we can explore, like we'll check with the other paths. So from 2 we'll backtrack to this node, and we checked with up, we checked with down, we never checked with left, so now we'll check with left. We can't move left, so we'll check with right, so we move to right. And here we'll mark this as visited previous node, and now from here we'll check if we can move up or not. So we can move up, so we'll move up, marking this as visited. Yeah, and from here we can't move up, left or right, so we'll just return back as this is not the ending node. So we'll backtrack and move and mark these nodes as visited, like we'll mark those as unvisited again by backtracking. And we came here, so we explored all the paths, so we'll backtrack again. From here we move down, so we are left with left and right, so we'll check if we can move left or not. So we can't move left, so we have to move right. So we'll mark this as visited, we'll move right. And from here we can't move up, we can move down, so we'll move down. From this node we can move up, we can't move down to as this is an obstacle. Okay, so now we'll check if we can move left. We can, so we move to this node, and from this position we can only move down, right? So we came to the ending node, and now we can see that we have traversed all the zeros, so the zero count will be 0 at the end when we reach to the ending node. So we'll increment the count by 1. Likewise, we'll find the path, like the second possible path, when we backtrack from this. So initially we took downwards position, right? We check with up, we check with downs as we could move down, so we moved down from here. But we never checked with left or right, so we can't move left from here, so we'll move right from here now. And then we'll explore all of the possible paths. So we'll get the second path also, and so we'll increase the path by 1, I mean the total count by 1, and so that will be the final output, right? Now let's have a look at one more example. The exploration order will be the same: up, down, left and right. Total count will be 0. Zeros count will be 2. And we'll start exploring from the starting node. We can't move up. We can move down. So we'll move down. We'll mark this as visited. And from this node, we can't move up. We can't move down. We can move left. Now we have reached the ending node. So we'll check if we have explored all of the zeros or not. We have left the 1 0 here, so we won't increase the total count. So now we'll backtrack from this position. We have explored with left, so we are left with right, but we can't move right, so we'll backtrack again from here. From this node we have explored the down path, but we haven't explored the left path, so we'll go left and we'll mark this as visited again. So at this node we'll check if we can move up. We can't. If we can move down, we can. So we reach the ending node again, and we haven't traversed all of the zeros, so we won't increase the total count again. So at the end, if we explore all the paths, we will get to know that we can't form a path exploring all of the zeros from the starting node to the ending node. So the output will be 1 for this input. I mean 0 for this input. So this is the explanation part. Let's have a look at the coding part of it. Initially, I'll have zeros count as 1, and I'm taking zeros count as 1 and not 0 because in every DFS call we'll decrement the zeros count by 1 if the path is walkable, right? If the node is walkable. And initially in our DFS call, we'll start from the starting node, right? So to avoid that starting node, we'll just increase the zeros count by 1. After that, I'll have the total count as 0, which we're gonna return at the end. We'll have a pointer pointing to the coordinates of the starting position. I'll just initialize this, and we'll have a loop in which we'll find the coordinates of the starting position, and we'll we'll count the number of zeros also, right? So we'll have I less than grid's length I plus plus. Inside we'll have one more loop. So this should be z. And grid, this should be the length of grid 0. Yes, and inside this we'll check if the current value is 0 or not. If it's 0, we'll increment the zeros count, and if it's not 0, we'll check if that value is 1. If it's 1, we'll just update the coordinate of the starting index, right? Start x and start y would be j. And after this, we'll have our helper function. We'll pass the grid, we'll pass the coordinate of the starting node, not index, and we'll pass the zeros count too. Right, now we'll define our helper function. So we'll have the grid, we'll have start, I'll take row as start x and column as start y, and I'm taking count for zeros count. Yes, so we'll have our edge cases here. If row is less than 0, or if column is less than 0, or if row is greater than or equal to grid.length, or column is greater than or equal to grid of zeros.length, or if that position is an obstacle, we have an obstacle in that position. Obstacle is represented as -1, so we don't have to do anything, we'll just return. And if it's not, then we'll update. Okay, it's not ij, it's row and column. We'll update the current, we'll mark it as visited. Okay, and we'll start exploring the other paths. Right, so we'll have up, down, left and right. So for up, we'll decrement the row count by 1. For down, we'll increment the row count by 1. For left, we'll decrement the column count by 1. And for right, we'll increment the column count by 1. And when we backtrack, we'll just add that, like we'll replace the value again with the value which was there before. Right. And I missed one more step. If this condition is not satisfied, we also need to check, right, if grid's position is the ending node or not. If it's the ending node, then we need to check if zeros count is equal to 0. If it's 0, then we'll increment the total count. So I'll define this here so that I can access it in that function. Okay, so total count plus plus, and we don't need to explore any further, we'll return from there. Right. And I haven't decremented the count. In every DFS call we have to decrement the count also. So yeah, this looks fine to me. Let's run and test this, if this works or not. And there's one, okay, so I missed the semicolon. Now, so again I have, okay, so I haven't incremented it. And again, zeros count is 0, we have to increment the total count. Okay, so I have defined that as count, right? So it works for this example. Let's test for this example too. So yeah, it works for both. Now let's just submit this and test this. And it works. So don't forget to like and subscribe. See you next time.
Drove the gates, feeling anxious around 12 a.m. Just move, but might move it all out again. This feel like deja vu. Swear last year my brain bought the same thoughts through. I blame the things I do. Only difference is I ain't in school. You heard that news? I flip birdies to these worms in suits. See, getting moved in a couple months.